Hi, I'm Max Clark. I'm going to talk about proxy servers. So if you've been on the internet since the 90s, you've dealt with proxy servers, and usually it was in a very negative way, right? We talked about the AOL mega proxy was the big challenge in the late 90s and early 2000s if you were hosting any sort of web infrastructure. And of course, at that point, AOL was the dominant player in internet ISPs. It's kind of a redundant term there. And just dealing with having all the traffic aggregate. Now, why were they aggregating traffic through the proxies? Well, it was network efficient for them. You know, proxies let you do fun things. What AOL was doing was it was doing content caching. It was doing network aggregation. It was doing a bunch of different things with it. Boy, we always had fun with the AOL mega proxies, and if you were running any sort of web infrastructure back there, you remember it. You have scar tissue of it. You've been dealing with session maintenance issues and persistence problems and all sorts of fun stuff. Now, proxies weren't all bad. I mean, there were places where you would want to use a proxy in your own infrastructure. Late 90s, early 2000s, internet connections were obscenely expensive. So when I started in networking, most small businesses were using dial-up to get on the internet. And you can go through the bowels and find Microsoft Proxy Server 1.0 and then update it eventually to 2.0. And it was just software that you loaded on one of the Windows and T4O servers in an office and connected to some modems to it. And what it did that was really cool is you could aggregate multiple modems together. So, you could have one modem on it and have 56K for an office, or you could put two modems on it, or heck, you could have four modems on it. And you could aggregate up to four modems on your dial-up. And this was dial-up ISPs. So 33.6 and 56.6 modems. And of course, this was because, the cost of ISDN and the cost of frame relay was just so expensive. Going out and putting a $1,500 frame relay circuit in a small office versus, two modems was just a different world. I mean, you're talking about a $100 a month expense versus a $1,500 a month expense. You wouldn't even argue this. It didn't go there. So in those cases, those proxies were pretty awesome. And then of course, eventually we had, DSL starting. Cost of frame relays and T1s came down. Then DSL came onto the market. 386K DSL was like this is the fastest thing I've ever experienced in my life, kind of conversations with people. And then DSL started getting faster and faster and faster. T1s got cheaper and cheaper and cheaper. Cable modems came out, yada, 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 history of the internet. So where else were we using proxy servers? Okay, so what this company was doing was it was taking, and if you were filming a movie in Czechoslovakia, more than likely if it was a special effects movie, which all movies are, you had some sort of effects company working, and the big ones, of course, were ILM in San Francisco, but most of that industry was centered around Los Angeles, or maybe you were in Weta Digital in Auckland, New Zealand. So you had to move data between one place and another. That was one example. Another example was then the special effects houses done work, and the director is in this other country or other location and wants to be able to review the work that they're doing with the effects supervisor to say, yes, they like it, or no, they don't like it, or what changes need to be made. Or maybe it was an application around digital dailies. Again, this is now maybe more common in the market, but was very cutting edge when this came out. And there was a few summers, every major summer blockbuster, used this network in order to move data. The trick here is when you're moving data across high latency links, you run into a window scaling issue. And you've experienced this yourself on your computer because you've taken and started to download something and you watch the speed on your download bar in your browser, and it starts slow and it scales up to a point and then it stops at that point. And you'll look at this and you get really frustrated because you say to yourself, I know my network connection is faster than how much data I'm getting here. And the answer is it is. And what's happening there is you are getting kneecapped, you're getting blocked, you were getting constricted by a really old artifact in the TCP/IP protocol, which is the send and receive window size within the network stack. And this default was set at a time when internet connections were really slow. It controls how much data can flow through it. It also controls the algorithm of how much data it starts with to send and then how it tests up to what its maximum transmission is, because your computer has no way of knowing how fast its network connection is and how fast the connections are in between, like here, your ISP, the whole mess of the internet and whatever the sending system is. And so the way it does it is it starts small and it keeps testing and growing until it finds its maximum. But your maximum is set by the algorithm, by settings that you have in your system. Now you can take and you can override these settings and you can increase this, and there were old registry hacks that would just go through and just arbitrarily increase these numbers by a factor of 10. That's not necessarily a great thing to do either, because there are some significant side effects and negatives that come out of that for you, especially if you're dealing with all of a sudden now a network that's not performing behaving properly, performing properly, or is just slower and you've hijacked your network settings on your computer and told it that it's supposed to be really fast. There are some commercial platforms that you could go out and buy, like Aspera was one big one. And Aspera worked around this by you'd have two boxes on both sides of the link, and you would send on one side would talk to the one box, this box would talk to this box would talk to whatever else you're talking to, right? And so it could accelerate the transfer between the two of them. And what the Asperas were doing was they're just using UDP versus TCP. And UDP doesn't have retransmit, doesn't have the testing, doesn't have this window sizing issue. So by converting from TCP to UDP and then transferring between the Asperas was basically like, you remove the governor, there's no speed limit, it just shoves as much as possible. And then, of course, the engineers with Aspera had to build in a lot of fancy software to do things that UDP wasn't designed to do, which, of course, is how you check some of your data transfer and make sure you're getting everything across it properly. So now what this company did that I was consulting for is we figured out how to build our own Asperas, for lack of a better word. And what those were just proxy servers. Again, this evil term can be a good term. And what these proxies were in each of these markets, so in Vancouver and Toronto and New York and in London, Australia, servers were put in place. And the servers connected into the had multiple network interfaces, one that went onto the backbone, one that was facing the customer, facing the end user. And now, because we had these proxies deployed on this backbone everywhere, we could test and figure out what the network latency was. And so I was running software constantly that was figuring out, the latency on this backbone between point A and point B and point B and point C and point C and point D, and all these different permutations of the network. What was the actual exact milliseconds of latency? And the point of all this was to be able to then compute and figure out the bandwidth delay product. And the bandwidth delay product is just a simplistic math where you say, I have this speed link and this milliseconds of latency. And so therefore the window sizes need to be X, right? So X plus Y equals Z, kind of thing. And so you create your window sizing at Z. And so that way, when you would talk to the proxy server, low latency link, the end user's computer could size itself and do its own thing, and everything was fine. But that proxy server then knew on its backbone link what window size to use. And instead of having that download, that status bar start small and come up to here and then cap, it would just start at full speed. It was just, like a turbocharger or throwing nitrous or whatever you want to call it. It was just there and it was good to go. And these proxies were a very inexpensive solution to this problem that created an end result. Now, Aspera came out and was running at that time, but again, this became a cost issue. I talk about this in a lot of different things, right? So you can go out and you can buy a commercial platform off the shelf and you can spend a fortune on it, or you can build it yourself if you know what you're doing and you can save a fortune. So this company created a competitive advantage for itself because it was not using expensive off-the-shelf, hardware from a manufacturer or from, and licensing it. And then because in that case, if they were using Aspera, every POP they wanted to create would have required an Aspera, and as they wanted to push more bandwidth, they would have had to license more in Aspera, and their costs would have always gone up. And what you want in your business is you want your costs to stay the same or to decrease as your volume increases, right? You want that efficiency. You don't want like these one for one, like, you sell a new customer and your cost increases. You want your cost to stay here and you want your revenue to increase, or you want your revenue to increase and your unit cost to decrease, right? So that's how we did that. Another hack that was really fun, I use the term hack, not in terms of like computer hacking with software, but hack in terms of like a, tweak of an approach of conventional wisdom, contrarian thinking, right? In terms of hack, a customer that accidentally ended up doing business in China. And when I say accidentally, they had an application SDK that got installed on cell phones via their software. And they noticed that all of a sudden they had a bunch of end user devices in China. China is a very interesting animal. First off, you have to have in-country representation. You have to have an ICP license. Your ICP license is based on the type of business that you're doing. Then based on the type of business, your intellectual property and your infrastructure is supposed to be inside of China. You can't move data out of China. There's all these rules and regulation and stuff that, maybe other countries should be doing as well. I won't get into that too much, that China enforces. So there's a lot of regulatory overhead with China, and there's also technical overhead with China, right? So to go and take and put servers into China is very expensive. It's also complicated if your application isn't designed to run, in this case, they were running almost all their application in US East 1. So to take and put a portion of that infrastructure in somewhere in China just to run the Chinese marketplace, the infrastructure, you have to redesign your application. You have a lot of engineering hours. So then you deal with the Chinese firewall. The Chinese firewall really does a couple things. It absolutely does enforce policy from the Chinese central government. So what can and cannot be transmitted in and out of China gets implemented from the Chinese firewall. The other thing that happens, and this is a product of the Chinese firewall, it's also a product of just the Chinese network reality of network links, is everything's always saturated. Everything, this has been this thing for, as long as I've been aware of network engineering on a backbone for ISPs, is some network turns up a peering link with China Telecom or China Mobile or China Unicom or any of the Chinese networks, and let's just say it's 100 gig, you turn on a 100 gig link and the link goes from 0 to 100 gig instantaneously, and it just saturates 100 gig. There's so much latent demand and capacity there that you just can't keep up with it. So a lot of the challenge of dealing with Chinese eyeballs or Chinese moving data in and out of China is just the network links are always saturated, right? This is why most of the solutions around private networking into China are just that. It's MPLS links in and out of China, just that way you don't deal with the saturation of all these public network links. Forget all the other stuff. Just sidestepping public interconnect, saturation, and solves a lot of your problems. Going in circles here. So going back with this customer. So this customer had an issue where now they had Chinese eyeballs accessing their application, and they were getting inconsistent performance to those applications, which of course inconsistent performance makes it very difficult to profile and to optimize performance. And then you got pissed off people because their stuff doesn't work right, and yada, yada, yada. And we were going down the road of figuring out how to put infrastructure for them into China, what it was going to take, what was the regulatory overhead, what was it going to require for them, how were they established operations, how to get the application loaded and running, what was this all going to mean, how much was it going to cost. Business requirements, regulatory requirements aside, we got to a number that it was going to be on a minimum basis, just bare minimal, to get infrastructure turned up inside of China for them was $100,000 a month. They were spending about $2 million a month on AWS. So they're going to have to spend 5% of that to bring up dedicated infrastructure inside of China. But now, you're looking at all of a sudden materializing $1 million plus a year in IT infrastructure, an IT budget, just out of nowhere, right? I don't know what your budgeting cycles are like, but most people, if you come to them, you say, hey, by the way, you got to spend an extra, you have to increase your IT budget by 5% tomorrow just because. That conversation never goes very well. As we were going down this path, fortunately we had a really, really good relationship with this customer, made a proposal of doing a test. And doing a test in a manner that wasn't going to be all or nothing or all in, but massively asymmetric benefit and leverage benefit if it worked. And that bet was just simply that we were dealing with nothing more than just inconsistent latency, variability, and saturation of the network going into China for their application to work. And that they didn't actually have to go into China. They just had to deal with alleviating that issue. And what we did to alleviate that issue was we contracted with the Chinese networks, who all land on the west coast of the United States, to interconnect and peer. And we took 10 gig circuits from those networks and we put them into a data center. And in that data center, we put proxy servers. And those proxy servers had one network connection that was facing the Chinese networks and one network connection that was facing a direct connect. And back then, the direct connects were not universal, so we had to use an intermediary network that could then backhaul from the West Coast into Ashburn, Virginia, in order to interconnect with AWS. All of the ingress and egress traffic to and from China for this customer came in and out. So it went, China network, proxy server, intermediate network, direct connect, AWS, and back and forth. Didn't solve a latency issue. I mean, you're still dealing with talking about going from like China around the globe to Virginia. I mean, it's a lot of network segment. It's a lot of distance. But what it did do was it alleviated the choke points on the network, created consistency and predictability of that network traffic, and it solved the problem. And instead of spending, $1.2+ million a year to solve this problem, plus operational overhead to split their application, do everything else that would have been who knows what, an engineering distraction, what would have been who knows what, they spent less than $10,000 a month to put this proxy in place and solve the issue. So the trick here becomes, and the moral of these stories are, if you go to an engineer and you say, I've got this problem and I need to solve it, a lot of times that engineer will solve the problem that you face them with. The challenge is actually understanding what the business is trying to do, and is there a different way to solve the problem? What's the end result that you actually want? In the last case, the customer needed better performance into China, so that way their Chinese eyeballs could use their application, they could generate revenue. Business does not care what way that actually takes place. Given the choice of spending a lot of money or a little money, of course, the business always cares and is going to try to use the cheapest way possible. And our goal is to find and implement technology and solutions within the tech stack that gives leverage and the maximum value, per dollar spent. So it would have been really easy to solve this problem by spending $1 million. Instead, we spent 100K. That 100K created a lot of leverage in that environment to then, continue to grow the business, serve that traffic, and have a competitive advantage. Same example earlier with global proxies. Having a leveraged competitive advantage versus going out and licensing and having one-to-one costs. This is where tech excels for your business, and understanding where and how to apply tech to your business, not to solve a business problem, but to actually create additional leverage for you and, increase margin, create more revenue opportunity, whatever you want to call it. We can use all the fancy, business mumbo jumbo terms, but at the end of the day, the fun things that we get to do is we get to create and craft solutions to solve business problems and create leverage for that business so that business can grow and excel. So I'm Max Clark. This is a quick thought. I hope it helps you in some manner.